Electrical work is one of the most rewarding trades, but safety must always come first. Every electrical apprentice or trainee must master the safe isolation procedure before starting work on any circuit. Safe isolation ensures that there is no live electricity in the circuit, protecting you from electric shock and preventing accidents. In this guide, we'll cover everything you need to know to perform safe isolation correctly and confidently. Step 1. Understand the importance of safe isolation. Before touching any wires or terminals, it's essential to understand why safe isolation matters. Electrical circuits carry potentially lethal voltages. Even a simple 230-volt domestic ring circuit can cause serious injury or death if handled incorrectly. Safe isolation prevents live exposure while allowing testing, fault finding, or installation work to proceed safely. Every professional electrician follows a 5-step safe isolation procedure, and these steps are required by UK regulations, including BS 7671, requirements for electrical installations. Memorizing and consistently applying this procedure is essential for any apprentice. Step 2. Identify the circuit. The first step in safe isolation is to identify the circuit you need to work on. This may involve referring to the consumer unit labeling, checking the circuit diagram if available, using a circuit tracer if the circuit isn't clearly labeled. Tip: always double check the labeling. Misidentifying the circuit can be dangerous, especially in older homes where documentation may be inaccurate. Knowing exactly which circuit you will isolate prevents accidental energization of the wrong circuit. Step 3. Switch off the circuit at the consumer unit. Once the circuit is identified, 1. Go to the consumer unit. 2. Switch off the appropriate MCB or remove the fuse for that circuit. 3. If possible, apply a lock-off device to prevent anyone else from turning the breaker back on while you work. Switching off the breaker alone is not enough. Locking off the breaker is a key safety step in professional practice, and it reduces the risk of someone unintentionally energizing the circuit while you are working. Step 4. Test for voltage. Prove the circuit is dead. After switching off the breaker, you must confirm that the circuit is actually dead using a proving unit or voltage tester. This is a critical safety check. Follow these steps. 1. Turn on your proving unit or tester and confirm it works on a known live source. 2. Test the circuit terminals or points you intend to work on. 3. Ensure the tester indicates no voltage. Always test the tester first, then test the circuit, and finally retest the tester on a live source. This 3-step verification ensures that your tester is working properly and that the circuit is safe. Step 5. Apply locking or warning devices. Once the circuit is confirmed dead, you can apply any additional safety measures before starting work. Lock-off tags. Warning notices on the consumer unit, barriers if working in shared spaces. These devices alert others that work is in progress and prevent accidental energization. Step 6. Visual inspection. After isolating and proving the circuit is dead, perform a quick visual inspection. Check for damaged cables or terminals. Look for signs of moisture, wear, or overheating. Ensure your tools are safe and correctly rated for the work. Visual inspection adds an extra layer of safety before any physical testing or installation work begins. Step 7. Proceed with work only when safe. Once the circuit is isolated, tested, and verified, you may proceed with continuity testing, insulation resistance testing, repairs or replacements, adding new outlets or circuits. Never skip safe isolation, even for small or simple tasks. Many electrical accidents occur because professionals or apprentices assumed the breaker was off. Always follow the procedure in full. Step 8. Common mistakes and how to avoid them. Even experienced electricians make mistakes. Here are the most common pitfalls when performing safe isolation. 1. Skipping the proving step. Always test the circuit, even after switching off the breaker. 2. Not testing the tester. A faulty tester gives false confidence. Always prove the tester before and after testing. 3. Assuming labeling is correct. Check every circuit carefully. 4. Removing lock-off devices too early. Only remove when the work is complete and the circuit is ready to energize. 5. Working on circuits with multiple phases or RCD protection without. Understanding. Some circuits may appear dead but are energized elsewhere. Being aware of these mistakes helps apprentices avoid accidents and ensures compliance with regulations. Step 9. Record your actions. Professional electricians document their work. Record the circuit isolated, the steps taken, results of voltage tests, any lock-off or warning devices applied. Documenting ensures accountability and provides a reference for inspections or future work. It also demonstrates professional practice to supervisors or instructors. Step 10. Re-energizing the circuit safely. Once your work is complete, safely restore the circuit. 1. Remove any lock-off or warning devices. 2. Double-check that all terminals are correctly connected and safe. 3. Switch on the MCB or replace the fuse. 4. Test the circuit under load to ensure it functions correctly. Never assume everything is fine. Always verify after re-energizing to prevent post-work faults or hazards. Step 11. Best practices and tips for apprentices. Always follow the 5-step safe isolation procedure. Wear appropriate PPE, such as gloves and safety glasses. Keep your tester calibrated and in good condition. Never rush the isolation process, safety comes first. Practice the procedure regularly to build muscle memory and confidence. Mastering safe isolation builds the foundation for all future electrical work, from testing ring circuits to installing new wiring systems. Step 12. Summary: safe isolation is the first and most critical step in any electrical task. To summarize: 1. Identify the circuit. 2. Switch off the breaker or remove the fuse. 3. Apply any additional safety devices. 6. Inspect visually. 7. Proceed with work only when safe. 8. Document your actions. Re-energize safely when complete. Following these steps ensures that every apprentice, student or professional can work safely and comply with regulations. Or conclusion: understanding and performing safe isolation correctly protects your life, the lives of others, and the integrity of the electrical system. Apprentices who master this process gain confidence, develop professional habits, and reduce the risk of accidents. Always approach electrical work with caution, follow the procedure step by step, and never take shortcuts. Remember, safety is always the first priority in electrical work. By mastering safe isolation, you're building the foundation for a long, successful, and safe career in the electrical industry.